Is it possible to hold it? Oh, okay.
No one is there.
Yeah. How many students today?
Yeah, most of them. All of them.
Most of them. Okay. So where were we in the last class?
We were doing pulley. We have some small part left.
Acha.
And then we have to go for the next chapter.
Okay. Small part means where we ended. Did we do combination of pulleys?
Yeah, yes. We also did block and tackle for 5 pulleys and also for 4 pulleys.
Really?
Yeah. Yes, so we did a lot of things. In one day we completed most of the parts.
That's right.
We completed except of 8 of pulleys.
So I think we did not do that efficiency part, right? The last part.
Yes. So we have done that. Efficiency. This one.
No, not that. This
Not
is
that.
ideal, no? This is ideal 100%. Efficiency is never 100% because MA reduces.
Because of it.
Okay, so
But then after this we'll do the numericals.
yeah, we'll do some numericals. Previous board questions we'll do. Then some of classwork numericals we'll do and then we'll go.
So we'll start a new chapter today?
Yeah.
Okay.
Reflection of light. So maybe in the first half, whatever numericals we are able to do, we'll do. Where are the boys?
All of them out.
Are they thinking I'm not in? Please go and let them know.
I know they are coming now.
Please sit down. Welcome back, everybody. We missed some of you in the last class. So I think the class is full today, right?
No, sir. No, sir. Some people are absent.
How many are there? Two. Okay, so let's resume. Quickly review what we did in the last class. We're asking some questions. So we did single pulley. What all machines we covered? Single pulley, single fixed pulley, right? Somebody smoking cigarette here? Outside, I mean. It's leaking inside. Okay, single fixed pulley. Single fixed pulley. Then we have
single movable pulley.
movable. So quickly write down MA for this. So we'll write down the MA here, okay? What is the mechanical advantage for single fixed pulley?
Mechanical advantage
Is one, right? So what does it mean? It just changes the direction, right? Then you had single movable pulley. So what is the mechanical advantage of single? Yeah, movable.
Greater than one.
Yes. Yeah, so it's 2, right? Then you have single movable plus 1 fixed. 2, right? Mechanical advantage 2. Only thing you get is change of direction. 4, combination of pulley, right? So we had 1 fixed plus 3 movable. Right? Let's say 1 fixed and n movable. What's the mechanical advantage? 2 raised to n. Very good. So for 1 fixed and n movable, you have 2 raised to n. Any dispute on that? Okay? So that's 2 raised to n. Fifth क्या था? Block and tackle. Tackle with n pulleys. This is n. Okay. So whatever is MA, same is VR. Same is the velocity ratio. So velocity ratio also will be same. 1, 2, 3. So this we have covered the ideal cases for all, and for all of them the efficiency is 100%. Okay, right? But now we'll see that the mechanical advantage is less than VR, right? So what was the formula for efficiency? MA upon VR. So mechanical advantage is equal to VR only in ideal machines, right? In reality, MA is less than VR. Why? Because if you take the block and tackle system, right? What do you have? In the block and tackle system, so you have yes. So now we are doing is efficiency is always less than 1 since mechanical advantage is less than VR. Okay, so let's see for a block and tackle system and why it is so. Because in all these cases we assume that the lower block has no weight. We assume the lower block is massless. But in reality, that's never the case. Right? And this one is smaller. So how do we run the strings? Let us say we run the strings like this. Then we run through the extreme blocks. This is all. Okay, and the load is this. So now what you're assuming is how many segments of strings are supporting the load? 2, 3, 4 and 5. Right? So now imagine that the lower block has weight W. Right? While deriving this efficiency, we said lower block has no weight, the strings are inextensible and massless, and there is no friction between the pulley and its bearing. Right? That is what was assumed. In reality, there is some mass, some weight like that, because we are dealing in force. Weight of the lower block, say W, right? And there is friction between the bearings of the pulley and axle. So pulley is mounted on the axle and there is a bearing between pulley. You know bearing, right? Ball bearings are there in the cycle. Wherever there is a wheel, there is a bearing. So due to which the efficiency becomes less than 100%. There is some weight. So that weight, say W. अच्छा वो लिखा तो है. So what happens due to this? Now the weight of the lower block and the load is supported by tension, right? So now weight plus load is equal to 5T, right? In general, let us say NT, where N is the number of pulleys. If this block and tackle had N pulleys, so what it will be? NT, correct? 1, 2, 3, 4, 5. There were 5 T's. So if there were N pulleys, then weight plus load will be NT. Got it? So considering N pulleys in block and tackle system, W plus L is equal to NT. So therefore L is equal to NT minus W. This is our equation 1. Okay. So therefore what is mechanical advantage? L upon E. So what is L? NT minus W upon E. So how much is this? And what is E? E is equal to T, always, right? E is always equal to T, correct? So I would write NT minus W by T. This is now splitting it, NT by T minus W by T. So this is N minus W by T. So whenever the lower block has some weight, then the mechanical advantage is not N. It is less by this factor, W by T. Okay, not factor, less by this amount. So if the weight is more, mechanical advantage is less by that amount. Okay. So what about velocity ratio? Velocity ratio is same. Right? What is velocity ratio? This is distance of effort upon distance of load. Now imagine the load runs by D, right? So how much string will release? It will all the 5 segments 1, 2, 3, 4, 5. It will release. So DL, DE is always equal to 5T or DE is equal to NT in case of impulse. Okay, so D is always equal to ND by D. So VR is always equal to N. So velocity ratio is independent of the weight of the lower block, right? But mechanical advantage is not. Okay, so what is the efficiency? Therefore, efficiency is equal to MA upon VR. This is equal to N minus W by T divided by N. So this is N by N minus W by NT. Okay, so efficiency is equal to 1 minus by N. So this is the actual expression of efficiency. What does this tell you? Therefore, efficiency is less than 1. So in real machines, you will never get efficiency equal to 1 or 100%. Okay? This is how we have proved. Because if you have a lower block, it cannot have WS 0. So what can we do to improve the efficiency? We should have the lower block with as minimum weight as possible. That. Okay. So this question is asked, and it is generally so it is shown here in the last part of the book. So there are sometimes questions on this. So it says for greater efficiency, the pulleys in the lower block should be as light as possible, and the friction in bearings of the pulleys should be minimized by the use of lubricants. Okay, that's it. So you can write this part. Effect of weight of pulleys on MA, VR and infrared. That's the topic. Effect of, what is it? Weight of pulleys on MA, VR and efficiency. So only there is no effect on VR. There is VR is same. So except VR, everything is affected. You read the fan. do the numericals. Page 47. So is everybody done writing? So today we will take turns in solving the numericals on the board. Okay. So whoever turn it is will come on board and try to solve it. Did we do this while solving numericals last time?
No.
So we'll begin with classwork numerical 1 on page 47. So we are following this pattern. Okay, this is the pattern we'll follow. How many rows we have? 1, 2, 3. Right? So it ends here. One, two, three. Okay. So your is turn 1. Yes. Who is calling?
I wasn't present last time.
So don't worry, we'll help you.
Sir, I also. Sir, I was no, because I was there in
Those who are absent, I'll help them. Okay? But you have to come on board.
So, but
Yeah.
if you don't get the answer, you'll help us.
Of course. Arey Baba, it's a joint exercise. It's not your exam, okay? We are trying to Do numerical solution. Can I clean this? See, the thing is, unless you don't come on board, na, तुम्हारा full brain काम नहीं करता है. And you will realize where are the mistakes you are doing. Right? Okay. So do all the mistakes here. We'll fix it so that you're ready for exams. So this is a workshop. Better is it better. It's quite warm, comfortable behind. So are we ready? Volume.
So we don't have the volume.
What? You have not received it? One desk, one volume. Everybody come on page. Each desk has a volume? Yeah. So page number 47, classwork numericals. Question 1. 47. Classwork numerical 1. Can we cover the review questions? Page 46. So quickly we'll cover the theory first. Okay. So those who are absent,
So which page the numericals are?
46. First you come to 46. When numericals are on 47 classwork. Can you see classwork?
No.
Yeah. So first we'll do review question, which is theory. So pura revision ho jayega. So first you read first question. Review. Direct questions.
State 4 ways in which machines are useful to us.
Yeah.
It is force multiplier. It changes the direction to a convenient direction.
Force multiplier. It offers speed gain.
Speed gain.
Yeah.
And also
offers change of direction.
Change of direction and to a convenient point.
Point of application of effort at a convenient point. So these are the 4 things offered. Next, please. So how many students are there today? So let me write 1, 2, right? Then you have 3, 4, 5, 6, 7. Then you have 8, 9, 10. So this is your temporary identification, okay? This is your roll number, right? So right now it is 2. 2 is reading. Second question.
Give an example for each of the quadratic uses of a machine. To obtain gaining force, Caesar.
Caesar will obtain gaining force? No. It will obtain gaining speed. Shear will. You know what is the difference between Caesar and shear? Huh? So what is Caesar? Dekho. Caesar is big. It has a big blade. Right? This is your Caesar. But what is shear? Shear is this. This is shear. So to cut metal plates or garden, have you seen gardens? Chopping of trees and all. Not trees. What do you call bushes? Shrubs and. So this is shears. Everybody look here. So everybody has to be on the same question, right? These are shears. These are scissors. Is the difference clear? So this is force multiplier, right? Because here DE is. So for machine, what is mechanical advantage for machine? It is effort arm upon load arm, right? This is what we found out. which we had written in symbols as distance of effort upon distance of load point from the fulcrum. What is this DE and DF? Huh? What is DE and DF?
Distance of effort.
This is F, this is L, this is E. So distance of effort is
D and D.
or it is also called as effort arm.
Effort arm.
Be clear with all this, right? This is distance of load. So this is load arm. And it is a equilibrium case. So effort, how we got this? So load into load arm is equal to effort into effort arm. Therefore, load by effort is equal to D by DL. This is how we got. MA is equal to, ठीक है? So last class में जो absent थे उनके लिए, how did we define all this mechanical advantage of the machine? Did you not see the video lecture for the last class? जो absent होता है, as a rule, he has to see the video lecture and only then attend the next lecture. नहीं तो तुम्हें कोई फायदा नहीं है. Next lecture कैसे समझेगा तुमको? है ना? So anybody who has not attended the last class has to go through the video lecture only then attend. Otherwise बहुत gap है तुमको. 3-3 घंटे का lecture है. ठीक है? तो अब देखो, समझ आ गया? So shears will have force gain.
Which is the point of application of force bicycle.
Yes, give an example. Bicycle. Yes. Next,
Which is the direction of force pulley.
you have to say fixed pulley.
Fixed pulley.
Okay, whether movable or fixed. What you will say? Fixed pulley. Okay.
To obtain gauge space scissor.
Caesar. Very good. Okay. Third.
Explain the term mechanical advantage. State its meaning. Mechanical advantage is the ratio of load to effort and
Correct.
it has no
Has no unit because it is force by force. Okay. Very good. Fourth.
Define the term velocity ratio. State its theory. Velocity ratio is the ratio of the velocity at which the effort moves to the velocity at which the load moves.
Correct. So both are same physical quantity. So will it have units? No unit. Right? Same ratio of same physical quantity will have no units. Right? So velocity of effort upon velocity of load, which is also equal to displacement of effort upon. I'm asking you. One is velocity ratio is given as VE upon VL, which is also equal to DE upon DL. Okay. What is DE and DL there? Velocity is rate of change of displacement. So DE क्या होगा? Displacement of effort. ये DE same है क्या? This DE is effort arm. It is not displacement of effort. समझ आया? ये फर्क है velocity ratio में और mechanical advantage of machine के definition. Okay. Right. Next question.
Define the term efficiency of a machine.
हाँ.
Efficiency is defined as the ratio of output to input is expressed in percentage.
हाँ. Output work to input work. ठीक है. That is one definition of efficiency. And when we use that definition, then we will derive efficiency is equal to MA by VR using that definition. So the original definition of efficiency is work output divided by work input. Okay? And using that we can derive this MA by VR. So yes, you did it right. So everybody got what is the definition of efficiency? Define the term efficiency. Everybody got it? Okay. Next, question 6.
Define the term mechanical advantage, velocity ratio, and efficiency as applied to a machine. Name the term that will not change for a given design. Derive the relationship between the three terms.
So you have to derive the relation between efficiency, mechanical advantage, and velocity ratio.
Efficiency equals to MA upon V1.
So that you have to derive. How can you derive? By starting with eta is equal to W out upon W in. W out is, output is load into distance of load, displacement of upon effort into displacement of effort. So then you get L by E, and then you get 1 upon DL by DE by DL. So you get MA by VR. Okay? And define the term mechanical advantage, velocity ratio, efficiency. All three of you have already done it. Okay? Got it? How to do question 6? Everybody got it? Yeah. So the derivation ke liye, what is the starting point? Listen. Relation between efficiency is work output by the machine to work input on the machine. The work output is the load which is moved by displacement dl. Input is effort which we are applying on the machine, and this we are applying, right? Effort. So this is distance of effort, displacement of effort, and this is the load which moves. Okay. So this is what it is. And what is, then we separate it, load by effort into 1 by d by dl. So this is for question 6, right? So 1 by d by dl is, what is d by dl?
VR.
VR, right? And what is L by E? MA. So this is the relation between efficiency, mechanical advantage, and velocity ratio. I have done it in theory. This is the answer to question 6. The derivation of the relationship part. Okay. Rest everything you know. Yes.
What is a lever? Stated its principle. A lever is a rigid body which is capable of turning about its axis.
So rigid rod, like, I mean. So any straight rod, okay, which is fixed at a point, right? Okay, this is called as a lever. Any straight or bent rod which is fixed at a point is called a lever. So there are only 2 types of machines that we have learned in this chapter. Pulley and lever. So lever is straight rod, pulley is a round disc with a axis in at its center. Okay. So this is our lever. Then depending upon where is the fulcrum, where is the fixed point, this fixed point is called fulcrum. Then we have load and we have effort on the other side. Right? In other case, this fulcrum is on one side. So what are the 3 types of lever we have? Quickly.
Class 1 lever.
Class 1, class 2, class 3. देखो, class 1 में क्या होता है? Yes.
Load and effort on both the sides.
So fulcrum is in the middle, class 1 में, ठीक है? Load and effort on either side.
Class 2, fulcrum on one side, load in the middle and effort on the other.
So class 2 is fulcrum, load is in the middle, effort is on the other side. Class 3 में क्या होता है? Fulcrum एक ही side में, now effort in between, and you have load on the other side. ठीक है? So examples. This is a Caesar, बहुत सारा है. और इसका MA क्या होता है? It can depend. Like it could be equal to 1, greater than 1, less than 1. क्यों? क्योंकि fulcrum can be anywhere. It is not fixed. So fulcrum change होगा तो DE DL भी change होगा. So when DE is greater than DL, उस time पे MA greater than 1 हो जाएगा. When DE is less than L, it will be less than 1. When it is exactly in the middle, it will be equal to 1. Got it? Yeah. Now here, DE will never be less than 1. It will always be greater than DL. So it is speed gain, correct? DL यहीं तक है, क्योंकि DL बीच में आ गया. इस केस में क्या होगा? So this is always a force multiplier because mechanical advantage is always greater than 1 for this case. So जो भी absent था ध्यान से सुनो, clear हो जाएगा तुम्हारा यहाँ. इस केस में MA will always be less than 1. So class 2 हमेशा force multiplier. Class 3 always speed gain. Got it? Okay. So this is how it is. Speed gain means the machine will work faster for you. You will be able to finish work faster. That is speed gain. Okay. Force multiplier means in less effort you will be able to lift large load. जो हम इसमें करते हैं रॉड वगैरह पे बड़ा सा लोड है, एक छोटा सा स्टोन रखा, हमने यहाँ पे इसको एफर्ट किया, तो we are able to move large load. That's your class 1. Is it clear now? So what was the question? Whose turn it was? So what is a lever? State its principle. So what is the principle of lever? Yes. Effort down upon load down or wait. This is the principle. Okay. So lever works on equilibrium. So at equilibrium, load into load arm is equal to effort into effort arm. ये है principle. और इसी से we get this formula. Is it clear?
Yes.
Everybody now knows how to answer the question. So what is the principle of lever? Yes, what is principle of lever? वही जब बोल रहे थे तब सुनते नहीं हो तुम लोग. Principle of lever is यही है, at equilibrium load multiplied by load arm is equal to effort multiplied by effort arm. And इससे क्या मिलता है हमको? ये मिल जाता है. Load by effort is d by dm. मतलब load upon effort is mechanical advantage is equal to effort arm by load arm. यही principle है. ठीक है? उस principle से we are calculating all this. हर class का mechanical advantage क्या है? Is that clear? ठीक है? चलो. तो principle भी हो गया. 8. Write down a relation expressing the mechanical advantage of a lever. वही effort arm by load arm. किसका था ये? 8 का था. 8 कौन है? हाँ. क्या था तुम्हारा क्वेश्चन?
Write down a relation expressing the mechanical advantage of a lever,
Which is
effort down upon a load.
ठीक है. 9.
Name the three classes of lever and distinguish between them. Give the examples of each class.
Right. तो बताओ, what are the three classes of lever? Board पे है.
Class 1,
Class 2, class 3, right? What distinguish? What is the difference between each one of them? In class 1, देखो लिखा हुआ. In class 1, fulcrum is in the center. Load, बोलो.
In class
No, पूरा बोलो. Class 1, fulcrum is in the center, and
load is in right side.
load and effort are on either side. ठीक है. Class 2 में
Fulcrum is on either side.
no, fulcrum is on one side.
Yeah, fulcrum is on one side and effort is on one side and load is between.
Yes, in the middle. ठीक है.
And in class 3, fulcrum is one side, load is one side, effort is in between.
Correct. ठीक है. तो ये प्रैक्टिस करोगे तो तुम्हें आर्टिकुलेट करने आ जाएगा. Give 2 examples of each. Class 1 का 2 example बताओ.
Seesaw, scissors.
Yes. Class 2.
Lemon crusher.
Yes. और हाँ ठीक है. दोनों सेम टाइप का है. चलेगा. Class 3. टोंग चिमटा मत भूलना. Knife also, yeah, effort in the middle. Knife and tongs. Sugar tong या फिर stone वगैरह रखने के लिए. ठीक है, चलो. So you have given this question. Okay. So सबका clear हो गया question 9?
Yeah.
10.
Give one example each of the class 1 lever. The mechanical advantages A more than 1 and B less than 1. What is the use of the lever if its mechanical advantage is less than 1?
Let's do one at a time. More than one का example बताओ. Class 1 lever तो पता ही है. Fulcrum in the middle. क्या बोलोगे class 1 lever?
Seesaw.
हाँ, seesaw. So what is the example of more than one? Seesaw is an example of more than one. Seesaw का मैकेनिकल एडवांटेज क्या है? सीसो में फलक्रम की तरह बीच में है ना, एग्जैक्टली बीच में होगा तो D will be equal to DL, तो MA 1 हो जाएगा सीसो। सीसो इज नॉट अ एग्जांपल ऑफ, हाँ नहीं नहीं, क्लास 1 चाहिए। व्हील बैरो में लोड कहाँ पे है? लोड मिडिल में। एक मिनट, व्हाट इज give one example each of class 1 lever with where mechanical advantage is, class 1 lever का एग्जांपल देना है जहां मैकेनिकल एडवांटेज मोर देन 1 है और जहां लेस देन 1 है, बिकॉज क्लास 1 में हर तरह का पॉसिबल है। ठीक है, तो क्लास 1 में मैकेनिकल एडवांटेज मोर देन 1, सीजर, सीजर का मैकेनिक नहीं, सॉरी दिस इज ये शेयर्स, क्योंकि हमारा क्या होना चाहिए, डी शुड बी ग्रेटर देन डीएल। देखो यहाँ पे डीएल कितना है, बस इतना सा है। हमारा काम किधर हो रहा है, जिधर काम हो रहा है वो लोड होता है, आउटपुट किधर मिल रहा है, कट कर रहा है ना, ये आउटपुट मिल रहा है। यहाँ पे इसने मेटल प्लेट कट किया तो डीएल छोटा है, डी बड़ा है। ठीक है, डीएल छोटा है, डी बड़ा है, तो हमारा मैकेनिकल एडवांटेज ग्रेटर देन 1 होगा शेयर्स के लिए। ठीक है, क्रोबार ऑल्सो, यस क्रोबार ऑल्सो। तो ये अच्छा क्वेश्चन है। मोर देन 1 हो गया, लेस देन 1 किसके लिए होगा, सीजर के लिए। ये बहुत अच्छा है एग्जांपल। ठीक है, क्लास 1 में ऐसे कंफ्यूजिंग क्वेश्चंस आते हैं, तो तुमको हर टाइप का मालूम होना चाहिए क्लास 1 में। ठीक है, क्योंकि फलक्रम हमारा कहीं पे भी हो सकता है। समझ आ गया सबको क्वेश्चन टाइम? ओके, अब इसमें जो लास्ट पार्ट क्या था, व्हाट इज द यूज ऑफ द लीवर if its mechanical advantage is less than 1? When the mechanical advantage is less than 1, machine कैसे काम करता है, force multiplier या speed gain? Speed gain। force multiplier में ma is always greater than 1। ठीक है, चलो ये क्वेश्चन क्लियर हो गया सबके लिए? So the answer is speed gain। mechanical advantage less than 1, it offers speed gain। Okay, back to 1। चलो करो।
Which type of lever has a mechanical advantage always more than 1? Give one example. What change can be made in this lever to increase its mechanical advantage?
Yes.
The type of lever is class 2 lever.
Correct.
The example wheelbarrow or nutcracker.
Yes.
What change can be made in this lever to increase? To increase the mechanical advantage, you can keep the load in the middle. No. Increase the
Increase करने के लिए क्या करना पड़ेगा? So what is this DL को short कर दो, मतलब shift the load towards the fulcrum.
and increasing the effort down.
Don't increase the effort down. Size नहीं बड़ा करना है, because एक बार machine तुम्हारे घर में आ गई, you can keep the load either close to effort point or you can keep it away.
So the middle one can be changed.
See, suppose you have a mango cutter, okay? Middle one can be changed, na?
The other
So
side.
the blade is still here. Blade is like this. This is fixed, right? So you can keep the mango here or you can keep it here. So when you keep the mango close to the fulcrum, the effort will be less.
Yes, and so mechanical advantage.
Will be greater than 1. Got it? Understood everybody? So what is the answer to question 11? What change can be made to this lever to increase its mechanical advantage? The load arm can be reduced by keeping the load close to fulcrum. Got it? So we can't change the size of the machine. Machine to we can change the position of the load by shifting the load towards fulcrum. Okay. Question 12.
Draw a diagram of a lever which is always used as a force multiplier. Class 2 lever act as a force multiplier.
Plier, shear.
Then we have to draw the lever.
Yeah, lever. तो यही है ना, क्या बोला lever?
Load in the middle.
Load in the middle मतलब ऐसे बनाना, fulcrum को थोड़ा पास में रखना है, like this. The effort arm should be bigger.
So load will be in the middle.
For which class?
Class 2 lever.
Which question is there?
12.
No. Force multi. अच्छा, always. हाँ, correct. Draw a diagram of a lever which is always used as force multiplier. Class 2.
So
Load will be in the middle. Yes. My mistake. Wheelbarrow. ठीक है? So this is
So the mechanical advantage will be.
very good. So see, this is how. ठीक है? Always बोला था mechanical advantage greater than 1. तो क्या हो जाएगा? Class 2. तो इसका एग्जांपल क्या है? व्हील बैरो. सबको पता है व्हाट इज व्हील बैरो? ये व्हील बैरो का डायग्राम है, देखो ये वाला. दिस इज व्हील बैरो. तो लोड कहां पे है? बीच में है. व्हील जिधर है वो फल्क्रम है. नट क्रैकर भी. यस, गुड. हां, 13. किसका है? हाँ बोलो.
State the type of lever which always has mechanical advantage than one.
हाँ, class 3. Yes. Draw lever diagram of such a lever. ये नीचे वाला है. हाँ? Force नहीं बाबा, fulcrum. ऐसा force मत करो, ठीक है? But example.
Example of third class.
हाँ. Third class मत बोलो, class 3 बोलो. Third class sounds very what do you call, demeaning, right? Offending, right? So, यहाँ पे effort लग जाएगा और load कहाँ पे लगेगा तुम्हारा? Knife and tongs, sugar tong और जो भी है. Knife ये, knife कैसे जरा explain कर सकते हो? Knife. So you are holding the knife here, ठीक है? और तुम्हारा thumb क्या प्रेस करता है? इधर, ठीक है? So when you are holding, this is fulcrum, right? Effort कहाँ पे लगा? इधर लगा, middle में. And load तुम्हारा क्या है? जिसको कट कर रहे हो वो कहाँ पे है? इधर, ठीक है? knife हम कैसे करते हैं? ऐसे ही करते हैं ना, ऐसे. यहाँ पकड़ा है, यहाँ से effort लगा, ठीक है? एफर्ट कहाँ लग गया? बीच में. तो ये 2 एग्जांपल याद रखना, टोंग एंड नाइफ और क्लास 3 और थर्ड क्लास ले. कौन सा क्वेश्चन किया अपन ने? नंबर 13. ड्रॉ अ लेवल डायग्राम ऑफ सच अ लेवर. 14 किसका है भाई?
Explain why the MA of the class 3 type of lever is less than 1. Why are they then used?
हाँ, क्यों लेस देन 1 होता है? क्योंकि देखो, अगर एफर्ट बीच में है तो तुम्हारा एफर्ट आर्म हमेशा लोड से कम होएगा. अगर एफर्ट हमेशा कम है तो कम ही होएगा ना. न्यूमरेटर हमारा ऑलवेज छोटा रहेगा. तो एमए हमारा क्या हो जाएगा? हमेशा लेस देन 1 होगा, राइट? क्योंकि एफर्ट आर्म इज, because D is always less than DL in class 3 lever. That's why MA is always less than 1. Okay? तो ये याद रखो. हाँ, सिंपल आंसर्स हैं बट याद रखो इसको. अच्छा, ये हो गया. Why are they used? MA less than 1 हमको क्या देता है? फोर्स मल्टीप्लिकेशन देता है कि स्पीड गेन? स्पीड गेन देता है, ठीक है? मतलब हम इससे अपना काम फटाफट कर सकते हैं, राइट? सो दैट्स व्हाट इट इज. यहाँ पे देखो, एक बार समझ लो तो तुमको मेमोरी स्ट्रेस लेने की भी जरूरत नहीं है. यू जस्ट अंडरस्टैंड इट वंस. ओके? जिसने लास्ट क्लास अटेंड किया उसको तो मेरे ख्याल से काफी अच्छा हो गया होगा. जिसने मिस किया प्लीज सी द वीडियो. हाँ, 15.
What is a single movable pulley? What is its mechanical advantage in the ideal case? A single pulley which has a fixed axis of rotation.
मूवेबल है तो फिक्स एक्सिस कैसे होगा?
A pulley whose axis of rotation is in motion.
Yes. ठीक है, लिखा हुआ है क्वेश्चन में व्हाट इज अ मूवेबल पुली, फिर बोल रहे हैं फिक्स्ड एक्सिस, है ना? तो ये देखो, इसका मतलब कंसंट्रेशन मिसिंग है. ये ध्यान दो, दिस इज द वीक एरिया. ठीक है, समझ आ गया अभी? तो सिंगल मूवेबल पुली इज अ सिंगल पुली whose axis is not fixed. What is its mechanical advantage? हाँ? 2 है भाई. तो ये देख लेना कैसे निकाला है. ओके? तो तुमने दोनों आंसर इसके फिक्स पुली के दिए. फिक्स पुली का MA क्या होता है? 1 होता है. तुम जरा मेरे को डायग्राम में बताओ कौन सा मूवेबल है कौन सा फिक्स पुली है. देखो इधर देखो, ये फिक्स पुली. क्यों फिक्स पुली है? क्योंकि हैंग है ये. यहाँ पे खाली स्प्रिंग मूव हो रहा है, पुली मूव नहीं हो रहा. ये पुली को स्प्रिंग पे हैंग किया होगा. तो ये स्प्रिंग ऊपर जाएगा तो पुली भी ऊपर ऊपर उठेगा. दिस इज मूवेबल पुली. लेकिन ये यूज करने के लिए कन्वीनियंट होगा क्या? नहीं. तो हम मूवेबल सिंगल मूवेबल के साथ में एक फिक्स पुली भी यूज करते हैं ऐसे. तो उसमें हमको मैकेनिकल एडवांटेज में कोई चेंज नहीं मिलता. मैकेनिकल एडवांटेज कितना है? 2 ही है. बट लेकिन अभी हमको इससे क्या मिल गया? चेंज ऑफ डायरेक्शन. इज दैट क्लियर? अगर मैकेनिकल एडवांटेज 1 होता है तो हमको क्या मिलता है? चेंज ऑफ डायरेक्शन. तो ये दो क्वेश्चन आते हैं. सिंगल मूवेबल पुली विदाउट फिक्स पुली और सिंगल मूवेबल पुली विद फिक्स पुली. So we don't get any gain in mechanical advantage when the fixed pulley is used with movable pulley. Just the direction changes to convenient. We just achieve change of direction. Okay. All right. So now I actually was going to solve numericals because since you all have not attended, तो अभी तुमको थोड़ा idea आ गया. ठीक है? So now it will be helpful to solve numericals. Okay. कौन सा क्वेश्चन किया हमने? 16.
Name the type of single pulley that can act as a force multiplier. Draw a label diagram of the pulley mentioned below. So single movable pulley.
Very good. Because its mechanical advantage is 2, which is greater than 1. सबको समझ आया क्वेश्चन 16? क्या था क्वेश्चन 16? फोर्स मल्टीप्लिकेशन चाहिए और सिंगल पुली होना चाहिए. तो फिक्स तो हो नहीं सकता क्योंकि फिक्स का मैकेनिकल एडवांटेज कितना है? कितना है? 1. और फोर्स मल्टीप्लायर के लिए हमको कैसा चाहिए मैकेनिकल एडवांटेज? मोर देन 1. 2 नहीं, मोर देन 1. तो 2 इज मोर देन 1. ठीक है. तो 2 किसका है? मूवेबल का है, सिंगल का नहीं. तो क्वेश्चन में क्या पूछा था? नेम द टाइप ऑफ सिंगल पुली दैट कैन एक्ट एज फोर्स मल्टीप्लायर. तो मूवेबल ही होना चाहिए. Draw the label diagram of the pulley mentioned by you. तो कौन सा डायग्राम बनाओगे? कोई भी बना सकते हो. ये भी बना सकते हो. ठीक है? क्योंकि स्पेसिफाई नहीं किया है. लेकिन अगर स्पेसिफाई करेगा सिंगल मूवेबल विद फिक्स तो तुमको ये वाला बनाना पड़ेगा. ठीक है? हाँ, तो ओनली सिंगल मूवेबल में सिर्फ ये बनाओ. ओके? ओनली दिस. All right. Then we have differentiate between
between a single fixed pulley and a single movable pulley.
Yes. Everybody listen. The difference between single fixed pulley and single movable
The
pulley.
single fixed pulley is fixed to a rigid support. The single movable pulley moves over the spring of it.
So axis of the movable pulley is not fixed. Axis of the fixed pulley is fixed. Simple. Keep it simple. ये तो एक difference हो गया.
Its mechanical advantage is 1.
Okay, listen. When any question is discussed, it does not mean you have a free time. You have to carefully listen. I am saying whenever everybody has to listen to what he is saying and read that question for yourself. It's not a free time for you to chat. Okay.
Single fixed pulley, the mechanical energy is 1. And
Mechanical advantage is 1.
advantage is 1. But movable pulley, its mechanical advantage is 2.
Right. So single movable pulley acts as force multiplier, and single fixed pulley acts as
To change the
direction.
of it.
ठीक है. Very good. ये हो गया. Yours. Your turn.
Name the machine which is used to multiply force.
Multiply speed, change the direction. Example दे रहा है. Force multiplier कौन सा दिख रहा है तुमको?
Crowbar.
कहाँ दिख रहा है crowbar?
In example.
सही है. आंसर ठीक है. मैंने बोला बोर्ड में कहाँ दिख रहा है बोल रहा है crowbar. Crowbar बनाया नहीं भाई.
Sir, I saw inside it.
ये है crowbar. I'll give you that. ठीक है? So you're right. So crowbar is correct. और कोई एग्जांपल जो बोर्ड पे दिख रहा है?
Scissor.
शेयर्स शेयर नहीं दिख रहा क्या? इसका डीएल छोटा है, डी बड़ा है. ठीक है, तो ये हो गया. सो नेम द मशीन विच इज यूज्ड टू मल्टीप्लाई फोर्स. ठीक है, तो यू कैन से क्लास 1 नहीं, क्लास 2 लीवर बोल सकते हो, बिकॉज इट इज ऑलवेज एन ग्रेटर देन 1. एनी क्लास 2 लीवर. ठीक है. मल्टीप्लाई स्पीड,
Scissor.
सीजर, यस. और एनी क्लास 3 लीवर. ठीक है. चेंज द डायरेक्शन ऑफ फोर्स.
Pulley.
Which pulley? एक मिनट आगे देखा. अरे क्यों डरा रहा है? हाँ? Which pulley? Which pulley? अरे सिंगल फिक्स पुली बाबा, अभी तो डिस्कस किया ना. डायरेक्शन चेंज. देखो ऐसे कंफ्यूज कर देते, कभी क्वेश्चन ही उल्टा पुल्टा पूछ के कंफ्यूज कर देते. ठीक है, लेकिन कंफ्यूज अपने को नहीं होना है. चलो, तो एक रिव्यू क्वेश्चन खत्म हो गया. कौन सा पुली डायरेक्शन चेंज करने का? सिंगल फिक्स पुली होना चाहिए. अभी इतना देर डिस्कस किया ना ये क्वेश्चन, इसलिए मैंने बोला जब एक क्वेश्चन डिस्कस हो रहा है सब लोग सुनो, तो तुमको रिपीट मिलेगा एक ही क्वेश्चन का आंसर. चलो, आर वी रेडी फॉर न्यूमेरिकल्स नाउ? Who said that? अरे बाबा, तो कब करोगे? अच्छा, यू आर डूइंग स्टिल. ऐसे बोलो ना, मैं डर गया. रिव्यू क्वेश्चन कैसा लगा सबको? समझ आया? हाँ, वी गेट द फाइनल पॉइंट्स. यही टेस्ट में पूछेगा तो अटक जाओगे, जबकि ये सब पढ़ा है. एवरीथिंग वी स्टडीड. Yeah, so we will tackle that now. Everything in life is tricky, right? But we have to decode that thing. क्या ये मिटा दो सब?
Yes, sir.
So now we'll start solving numerical with ID 10. You have to solve the first numerical.
9 and 10.
9 and 10. 8.
We have 10 से ऐसा उल्टा. We'll let the snake change the direction. ठीक है? हाँ, 10 9 ऐसे चलेगा. ये मैं क्यों करता हूँ मालूम है? I have seen very smart student अपना नंबर नोट करते हैं, फिर वो क्वेश्चन पे लग जाते हैं. तो I want to break that so that you listen to the question going on. मेरे को मालूम है, इसलिए मैं चेंज करते रहता हूँ. तो स्नेक की बजाय I will play cross, तो ऐसे 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 आएगा. So I will keep the predictability 0. ठीक है? This is just to get your maximum attention. इसमें होता क्या है ना कि बच्चे का attention सही नहीं होता, तो you're losing so much rather than gaining. तुम खाली अपने आप को सिक्योर कर रहे हो, अरे मैं ये क्वेश्चन सही बता दूंगा, लेकिन you're missing so much. Only focus on the question which is being discussed. You will learn this, और तुम्हें पता चलेगा कि it is more beneficial. Okay? अच्छा. So are you liking this? Let me. Okay. See. So I'll go hexagon kind of a thing. ठीक है? I will go like this. ठीक है? I do this. Division नहीं करते, so division भी करेंगे. We will go to one line and jump. Okay? वो सब करेंगे. So which pattern I am going to follow next? I will not tell you. Sure. ये पैटर्न भी बन जाएगा. ट्रायंगल बनाओ. Okay. So at the moment snake only. Now reverse order. 10 9. चलो पहला वाला करो.
A 4-meter long rod.
Everybody will focus on the question being read. ठीक है? हाँ.
A 4-meter long rod of negligible weight is to be balanced about a point 125 centimeter from one end. A load of 18 kVA is suspended at a point 60 centimeters from support on the shorter arm. A beam W is placed 250 centimeters from the support on the long arm. Find W.
So, whenever the question is big, okay, what trick you will follow? Do the question in parts. एक part solve करके चलेंगे, ठीक है? चलो, आ जाओ board पे. Numerical has to be done on board. चलो, come. So first you write all the given data and we'll first solve A. Use that pen. So this is students area. This part I will use to explain. Okay? So what you will write? This is question number. Write down question 1. Okay? In your area, question 1. What is given? Write down. Given. No, you do your, I will do mine. So this is won't get too long. So we have the supports. Everybody do for yourself. Is the diagram proportionate? 125 centimeter is the shorter arm, so 400 centimeter of stretch करो towards the other end. देखो ये अगर पूरा rod कितना है 400 centimeter है, right? This is 400 centimeter. अगर तुम्हारा support 125 पे है, तो other will be 275. तो proportionately उसको आगे लेके जाओ. अच्छा बना है diagram. मेरे से better है, थोड़ा बड़ा है तुम्हारा. हाँ, 400. तो कितना हुआ 275. हाँ, कहाँ से सपोर्ट से? सपोर्ट मतलब सेंटर सपोर्ट से. हाँ ठीक है चलो. तो एक बार डायग्राम ठीक से बन गया तो देन एवरीथिंग इज जस्ट इक्विलिब्रियम. सो विल फाइंड आउट. So what is part A? It says a weight W is placed at 250 centimeter. 250 centimeter from the support. Read the question carefully. Read the question carefully. A weight W is placed 250 centimeter from the support on the longer arm.
Short.
So which is the
Shorter arm, right? The question is shorter arm.
A? Read the A part. A weight W is placed 250 centimeter from the support on the longer arm.
Yes.
So which is longer and which is shorter? Left of support is shorter, and this is short arm, right? And this is long arm, right? तो कहाँ पे है? Your diagram is correct. ठीक है. Next. तो अभी क्या करना है? A. At equilibrium क्या होना चाहिए? At equilibrium. So देखो, at equilibrium क्या होना चाहिए? 18 kgf into 60. This should be equal to 250. मतलब ये क्या है? W kgf into 250. So since it is unknown, give me the rest. Unknown का unit नहीं लिखते हैं. Okay, the one which we are calculating, we don't write the unit. And this is 250 centimeter. So you have to find what is W. Therefore, W is equal to 18 into 60 upon 250. So centimeter cancelled. खाली kg है बचे. So this is what is the answer. How much do we get it?
4.32 kg.
कितना आ रहा है? 4.32. ठीक है, चलो. So this should give 4.32. Somebody verify.
Yes.
Okay. उतना ही आ रहा है?
Yes.
Okay. So we have done A part, right? B part में क्या है?
W is equal to 5 kgf. Well must it be kept to balance the rod.
So now we are not changing 18 kgf. Now let us say what load is hang now?
5 kgf.
So let us say 5 kgf is hang. अच्छा कहीं पे भी कर लो. तो अभी इसका इक्विलिब्रियम क्या बनना चाहिए? So 18 kgf into 60, ये तो पता ही है. This should be 5 kgf into x centimeter, right? Because we don't know where it has to be hang. तो अभी x is equal to क्या हो जाएगा? करो. X is equal to 18 into 60 divided by 5. 12 है. 18 into 12 कितना होता है? 216 centimeter, which is equal to 2.16 meter. समझ आ गया सबको? चलो, बैठ जाओ. Last part you can answer by sitting at your desk. So what class of lever does this belong? Tell me what class of lever it is.
Class 1.
Class 1. Why? Fulcrum in the middle. ठीक है? सबको मालूम पड़ गया? Very good. चलो, whose turn it is? 9. Everybody writing? तो लिख लो पहले. सबने लिख लिया? लिख के फिर आओ. तो ये समझ आया? If everybody focuses at one question, the whole class learns. हाँ? तो इसमें आधा तो चैप्टर 1 से था, इक्विलिब्रियम, ठीक है, एंड रेस्ट ऑफ द थिंग्स जो अभी हमने सीखा है. तो ये चैप्टर से खाली पार्ट सी था, ठीक है. सो दिस इज हाउ क्वेश्चंस विल बी आस्क्ड इन बोर्ड एग्जाम. ऐसे करते करते तुम्हारा सबका कॉन्फिडेंस बहुत बढ़ जाएगा. डरोगे नहीं फिर मिस्टेक करने से. ठीक है, चलो
Yes, sir.
अपर पार्ट
हाँ.
चलो अपना बुक लेके आओ, ये पेन है। Shall I erase everything on the board? So everybody should be free, when we are discussing two. Read the question.
The force of 5 kgf is required to cut a metal sheet.
Everybody listen, please.
A shears used for cutting the metal sheet has its blades 5 centimeter long, while its handle is 10 centimeter long. What effort is needed to cut the sheet?
Right. So what is given? You have given the force of 5 kg is required to cut. So what is it? Effort or load? Cutting the metal sheet, it is output side, load side. So it is load. So given load कितना है लिखो? L equal to 5 kg. ठीक है? The load is 5 kg. A shears used for cutting metal sheet has blade 5 centimeter long. तो blade कितना रन होता है? DL is equal to 5 centimeter. Displacement of load is 5 centimeter.
Well, its handle is 10 centimeter.
तो हैंडल क्या होता है? एफर्ट आर्म. ठीक है, अच्छा तो तुमको क्या निकालना है? एफर्ट इज इक्वल टू हाउ मच? एफर्ट निकालना है. हाँ, तो अभी हमारा प्रिंसिपल क्या है? एफर्ट इनटू एफर्ट आर्म इज इक्वल टू लोड इनटू लोड आर्म, है ना? एफर्ट कितना हो गया? therefore एफर्ट इज इक्वल टू L इनटू DL अपॉन DE. तो सब्स्टिट्यूट करो. L कितना है हमारा? 5 kg. DL कितना है? 5 सेंटीमीटर. DE कितना है? 10 सेंटीमीटर. सब यूनिट्स खत्म हो गया. तो ये कितना आ गया? 2.5 kg है. क्या किया तूने श्रेया? DE by DL is equal to एफर्ट तुमको निकालना है. तुमने क्या किया? बगैर सोचे तो भाग गई यहाँ से. ये गिवन है. व्हाट इज 5? L is 5. L इधर आना चाहिए. करेक्ट करो उसको आगे. तुमने ये अपना वाला किया और ये मेरा वाला उठा लिया है. इसलिए देखो यू शुड गो स्टेप बाय स्टेप. ऐसे या तो फॉर्मूला में ठीक से सब्स्टिट्यूट करो. D इंटू E इंटू D इज इक्वल टू L इंटू DL. तो इससे हमको क्या मिला? तुमको भी यही मिला. L अपॉन E इज इक्वल टू D बाय DL. ये आएगा ना? तुमको कैसे सब्स्टिट्यूट करना चाहिए था? L कितना दिया हुआ है? 5. तो तुम्हारा स्टेप्स ऐसे होना चाहिए. 5 upon E is equal to
DE is 10 and DL is 5.
DL. अच्छा वो तो तुमने एक इधर सब्स्टिट्यूट नहीं किया था. तो फिर E कितना हो गया? therefore E is equal to क्रॉस मल्टीप्लाई करो. 5 into 5 by 10 आना चाहिए. हमारा ऐसे आना चाहिए. तो ये होगा 25 by 10. तब 2.5 आएगा। ठीक है ना, एक चीज तुमने सब्स्टिट्यूट नहीं किया था, ठीक है, गलत नहीं था, एक सब्स्टिट्यूट नहीं किया है ना। ओके चलो, एफर्ट इज गलती समझ में आना जरूरी है, कहाँ पे मिस्टेक हो रहा था, ठीक है। चलो नेक्स्ट, एट, कोई हंसो मत, सबकी बारी आएगी, ठीक है। क्वेश्चन 3, व्हाट इज द गिवन डेटा? ये वाला मिटा दो ना, सबने लिख लिया है? पहले गिवन डेटा लिखो, एक डायग्राम स्कीमेटिक बना दो, सब इजी हो जाएगा।
So it is important for us to draw the diagram for all.
गुड फॉर यू, मतलब डायग्राम रहेगा तो मिस्टेक के चांसेस कम रहते हैं।
Diagram. But then if we make the wrong diagram, then
If you make the wrong diagram, then only God can save you. So better practice with diagram.
yes.
So full length of the crowbar is 1.5 meter. So there is a sharp end 1 meter at 1 meter. This is the effort. This is 1 meter. This is what I have understood. No, you continue. I am just making it progress. Draw the diagram for the arrangement showing the fulcrum, load, and effort with their directions. Actually, ऐसा होगा. Sharp edge here. And a load here. So load नीचे आएगा ऐसे. ठीक है, इसका effort भी नीचे आएगा. इसका fulcrum भी नीचे आएगा. ठीक है, तो हमको करना क्या? So load down कितना हो गया तुम्हारा? Load down is 0.5 meter. तो question क्या दिया हुआ है? First, what is load arm?
1 minus 1.5 minus
0.5 meter. Okay. Total rod is how much? 1.15. So 1 meter तो effort arm हो गया. What is effort arm?
1 meter.
AC is equal to 1 meter. ठीक है. What is mechanical advantage?
Effort into
MA का क्या फॉर्मूला होता है मशीन के लिए? DE upon DL, right? What is मशीन के लिए? लोड बाय एफर्ट तो होता ही है, लेकिन इन टर्म्स ऑफ देखो मैकेनिकल एडवांटेज होता है L by E which is equal to E by DL. कैसा है? लोड इनटू DL is equal to effort into VE. यहाँ से आया, ये होता है ना मशीन का फॉर्मूला. तो MA क्या होता है? लोड अपॉन एफर्ट which is equal to DE by DL. तो अभी इस क्वेश्चन में हमको क्या मालूम है? हमको D एफर्ट पता है और हमको DL पता है. एफर्ट इज 0.5 Load is 1. It is 0.5. So mechanical advantage is
1.
कुछ गड़बड़ लग रहा है बस इसके अंदर.
So the sharp edge below is having, which one is that? 1 meter.
So the mechanical advantage in this case is 1. Okay, उल्टा लिखे मैंने. D is 1. उल्टा लिखे. D is 1 by 0.5. This is 10 by 5 equal to 2. Effort arm is 1 meter. No, D is 1. DL is 0.5. Okay. The effort needed. Now, how will you calculate the effort needed? 4. So effort needed is.
We have been given effort on load arm.
So ये हो गया ना. E is equal to L into DL upon DE. यहाँ से effort इधर गया, ये इधर गया. So L into DL. ये फॉर्मूला याद रखो. इसमें से तुम्हारा सब निकल आएगा. ठीक है. So what is the load? Load is 75 kg. What is DL? 0.5. What is DE? 1 meter. So कितना आ गया? 5 5 से 25. 2 5 से 30. 37.5 kg. State the kind of lever. Class 1, right? Class 1. क्योंकि fulcrum किधर है? बीच में. क्या हुआ? Confuse क्यों हो रहे हो? ये फॉर्मूला सबको पता होना चाहिए. इक्विलिब्रियम का है. तो चैप्टर 1 का फॉर्मूला. ठीक है ठीक. क्लास 1. बिठा क्यों रहे हैं ना? अगला बच्चा आएगा उसके पहले. So what is the lever? समझ आया कैसे किया सब? हाँ? So why I'm doing parallelly is so that you will know कि तुम कहाँ पे mistake करते हो. Okay? सबको समझ आया कैसे करना है? This is because of equilibrium and that's it. So next. Next किसका है? 7. उल्टा जा रहा है ना इसमें. कैसे जा रहा है? 7 ना. There is that part. Very good. थोड़ा बड़ा बड़ा देखो. Effort unknown है. Effort into. Very nice. Good. Well done. So everybody understood this question? if the weight of, and he did the question without reading it. You have to read it for the class. But anyway, it's very nice. I'm so happy. सबको समझ आया what he has done? तो एग्जाम में तुम डायग्राम देख के थोड़ा कंफ्यूज हो जाते हो, ठीक है, लेकिन ऐसा कुछ है नहीं. The entire thing is the weight of the wheelbarrow is given और उसके अंदर जो sand रखा है उसका भी weight दिया है, तो you have to add it. 15 kgf. सबको समझ आया है क्वेश्चन? 15 plus 60, so total load is 75 kgf. Then the load is how far away from the fulcrum? Fulcrum is the wheel. Fulcrum क्या है? Wheel है. तो fulcrum से load का कितना distance it is given in the diagram? 50 centimeter. So load into DL, load arm, is equal to effort into effort arm. Effort arm कितना दूर है? हाँ? Effort arm is from fulcrum it is 150 centimeter, right? कहाँ से लेना पड़ता है हमको effort distance? हमेशा fulcrum से लेना पड़ता है, ठीक है? So it is 100 plus 50 because fulcrum is at one end, इसलिए 150 हो गया, ठीक है, good. Anybody needs help in this question? Question 4? नहीं. अभी 5th किसका है? Your turn. Come. So the rule is you have to read the question and then solve it, okay?
The diagram below shows a lever in use. A. To which class of lever does it belong to?
Chalo. Which class of
second
lever?
class.
Yes, because load is in the middle. Wheelbarrow ऊपर वही है. हाँ. Next.
If FA equals to 80 centimeters, AB equals to 20 centimeters, find its MA.
निकालो. So is doing second part for which first you will write the given data. You can comfortably face the board, no? Very nice. MA is 1.25.
Calculate the value of E.
So you write A, B, which part of the question it is? This is
second.
B, right?
Yes.
Question number?
5.
And C part is?
C part is calculate the value of E.
अच्छा, ब्रेक हो चुका था क्या? तो बताया क्यों नहीं? बताना चाहिए था मुझे. Anyway. See, it has become so interesting. Everybody is involved. Time पता नहीं चलता है when everybody gets involved. कुछ तो डर के मारे और कुछ enjoy कर रहे हैं इसलिए. ठीक है, चलो. The effort. This is the formula. D E into D is equal to L into DM. Very nice. Four आ जाएगा ना सीधे. 4 kg. Okay. So I think everybody got this answer. Was it good? Question 5 आने के बाद थोड़ा सा और करेंगे. We have one more part to go, right? After the break.
Yes.
So we'll solve till question 11 and I'll start the new chapter. Okay? Which is refraction of light. Okay. You what?
We have already solved it.
अच्छा पूरा कर लिया है? हाँ ठीक है, कोई बात नहीं. तो दूसरा क्वेश्चन दूंगा. ठीक है, चलो. बोर्ड पे आगे करना है.
अभी जब हम लोग चढ़ेंगे